So 6.3 is on something called polar coordinates. In fact, the rest of 6 that we deal with is on polar coordinates. And a polar coordinate system is a plane that has a point 0 called the pole, which is like what we would consider the origin in a normal rectangular graph with xy. Then there's a ray from that center called the polar axis. And then each point in the plane is assigned polar coordinates in the following way. The r is the distance from that center of that circle toward our point P. And theta is the angle that you are rotating around and then heading the direction of. And so let's look at a couple examples. If we were going to graph these points over here, if I was going to graph the point 5, 225, here's how I would actually recommend thinking of it. I would pretend you were standing right on the center of that circle, and I would do the rotation first. I would do the 225 degrees. So we start by default kind of pointed toward 0. And then I'm going to rotate. I'm still standing on the center, but I'm rotating around until I get pointed to 200. Oops. Okay, grab my arrow again now. There we go. Until I'm pointed at 225 degrees. And then once I'm pointed in the right direction, I imagine like this distance of 5 is like 5 steps. So I'm going out 1, 2, 3, 4, 5. Or I'll actually write it. If I started in the center, I'd be going out toward 225. I'd go 1, 2, 3, 4, 5 steps, and that's where my point would be. So we do the same kind of a thing with 11 pi over 6. We start pointed towards 0, and this time I've got to rotate all the way around till I'm pointed at 11 pi over 6. And then I would do my 1, 2, 3, or I guess 3 steps this time. 1, 2, 3. So if I actually draw that on here now, I am starting at the center, walking out toward 11 pi over 6, 1, 2, 3 steps, and that's where my point would go. So this one was the 5, 225, and the 3, 11 pi over 6. So that's just plotting points. One of the things you're going to have to do is convert back and forth between normal xy points called rectangular coordinates like we're used to, and polar points. And for the first sets of problems, you're going to be able to do it because they are convenient triangles. We're going to pick points on the unit circle, and because of that, you're going to end up working with 45, 45, 90 triangles or 30, 60, 90 triangles. And so just some reminders on how those work. If you have a 45, 45, 90 triangle, 2 of the legs are going to be the same. Those are the legs. And whatever that length is, the length of the hypotenuse is the length of those legs times the square root of 2. So, for example, if I have a 45, 45, 90, and my leg is 3 inches long, the other leg is 3 inches long, and the hypotenuse would be 3 times the square root of 2. And then we're done. If you want to go the other direction, let's say you have a 45, 45, 90. I'll draw it the other way just for variety. Sorry, that's a 5, but it's hard to squeeze it in there. If you start with the hypotenuse this time instead, let's say you knew the hypotenuse was 5. Well, in the first triangle, we started with 3. We had to multiply to get the hypotenuse. If you're going the other direction, we need to divide. So the legs, the length would be 5 divided by the square root of 2. But of course, we need to rationalize, so those 2 legs would really be, after we rationalize, 5 square root of 2 all over 2. And that's really how long both those legs would be. In a 30, 60, 90 triangle, we have 3 different side lengths because we don't have any matching angles. And whatever the shorter leg length is, the shorter leg is always the one next to the 60-degree angle That's a good thing to keep in mind because that helps when you start drawing these in on a unit with the polar coordinates to know that the one next to the 60 is the shorter leg. Whatever the shorter leg length is, you take that times 2 to get the hypotenuse, and you multiply by the square root of 3 to get the longer leg. And we're not going to do a zillion examples. We can't cover every combination. But what's going to happen in a fair amount of problems is they will give you the hypotenuse, and then the shorter leg is the one next to the 60. So the way I've drawn it here would be, there would be the 60, there would be the 30. So that means we take the 10 divided by 2, which should be 5. That gives us the shorter leg. Then we take the shorter leg times the square root of 3 to get the longer leg. Okay. So let's tackle some problems. Alright, so we're going to start doing some converting. And our goal here is to describe each point in the other form than it is given in. That should be than. So, if we're going to go from rectangular to polar, what we really want to do is draw a picture. So that'll help us kind of figure out what we're dealing with. If I'm going to graph the point 4, 4, if you think about what a axis looks like, positive 4 would mean go right 4, and then positive 4 for the y-coordinate would mean go up 4, and then our triangle is created by going back to the origin. And really, we don't need the full axes on there. We just need to see enough to see our triangle. So here's our triangle. And anytime you have a triangle where two legs are the same length, then this is a 45, 45, 90 triangle. To get our graph in polar coordinates, we need an r and we need a theta. We need to know how far this is rotating from 0, and we need to know how far to go out to plot our point. For us, what that really means is we need to know how far we're rotating from 0. That part's correct. But we really just need to know what is the hypotenuse of the triangle. No matter what quadrant we rotate to, the hypotenuse is always going to be our r. So in this case, you could do Pythagorean theorem, but this is a 45, 45, 90 triangle. So I already know that that hypotenuse is going to be 4 times the square root of 2. So then my coordinate, the point 4, 4, if I'm going to write it in polar coordinates, would be an r of 4 times the square root of 2, comma, that 45 degrees. The only thing we need to be careful of is if your point rotates over to another quadrant. So let's say I was plotting, this would be like a different problem, but let's say my triangle ended up over in quadrant 2. So let's say I went left and then up. So then my triangle connects back to here. If this was a 45 degree angle, and I had a 45, 45, 90, but I was in quadrant 2, my r isn't going to be 45. My r is going to be how far did I have to rotate to get to this side of the triangle. So in this case, it would be 180 minus 45, or 135. So that's not necessarily here. That's kind of our little side problem. But just be careful, your r or your theta isn't always the angle in your triangle. It depends what quadrant you're in, so that's another reason why a picture can be helpful. Okay, and then let's look at the second one here. Whoops. Here we go. That negative sign is supposed to be in front of there. So if we're going to plot the point 2, comma, negative 2 root 3, I would start at the origin, but then I would move to the right 2, and I would move down 2 root 3. And you can put the negative in front if you want. So, if I look at this, the length of this side, the length would be 2. The length of this side is 2 times the square root of 3. So that means my shorter leg times my shorter leg times the square root of 3 gives me my longer leg, the length. So I am dealing with a 30, 60, 90. And the 60 always goes short next to that shorter leg. So the 60 must be up there near the 2. The 30 must be down in that corner. And then I need, again, my angle of rotation, and I need my r. Well, my r is just going to be the hypotenuse, which is the shorter leg, times 2. 2 times 3 would give me 6. So my r here is 6. But here's the case where I have to be careful again about that angle of rotation. My theta is not 60 degrees, it's not 30 degrees. My theta comes from how far would I have to rotate from 0 to get all the way around to where I am. Well, a full circle would be 360 degrees. I'm not quite going a full circle. I still have this 60 degrees that I'm not going to go past. So the way I'm going to get my theta is actually 360 minus that 60. So my theta is actually 300. So then when we give our point in polar, the r would be 6. The theta is 300 degrees. All right, and then that's how we convert from rectangular to polar. Again, the biggest concern is just be careful with those angles if you're not in quadrant 1.